Fission, exponential energy. In this presentation, we will be going through what fission is, its origins, how it works, and how it is applied in the real world. Fission. So what is fission? First, let's define it. Fission literally means to break or to split. It is the process where an atom is taken and is split into two. This reaction creates two smaller atoms and an immense amount of energy, like a ton of energy, enough energy to power a city for a few minutes. But it is very important to note that fission can only be utilized on heavy unstable isotopes like uranium-235, so basically the scary radioactive ones. Fission was discovered by accident in 1938 by German physicists Strassmann and Hahn as they tried to create heavy elements by throwing a lot of neutrons at a uranium atom. Instead, they got the opposite outcome, and the atom split into two significantly smaller atoms, barium and krypton. Fission can occur in a few different ways: spontaneously, natural decay, or induced in a controlled environment. The process differs based on the technique used to initiate the fission, but the main idea is this: fission can only occur in heavy, unstable isotopes like uranium-235. This is because they are heavy elements that have lots of protons that are repelling each other and are barely being held together by their neutrons. The unstable state allows for the element to easily split or break apart when it absorbs that extra neutron. Induced fission is the most known and commonly used process to achieve fission, and is what I will be explaining. Let's get to the specifics. The process starts with taking an unstable element. Let's use uranium-235, a popular fissionable isotope. A uranium-235 atom is taken and is bombarded with neutrons. When a singular neutron successfully gets to the uranium, the already unstable element can't handle the extra neutron. This causes it to split into two smaller nuclei, or daughter atoms. These daughter atoms are not random. Since uranium-235 has 92 protons, the resulting daughter atom's protons must also add up to 92. An example would be uranium-235 splitting into strontium and xenon. The excess neutrons that are created from each reaction is also not random. You get them by taking the neutron of the unstable isotope used plus the extra one absorbed and subtracting it by the combined number of neutrons of the daughter atoms. For example, uranium-235 has 235 neutrons plus the added neutron is 236 total. Strontium and xenon combined have 234 neutrons total. 236 minus 234 is 2. This means that the reaction produces 2 extra neutrons. Now, the energy produced from a singular reaction is tiny and doesn't have much use. But fission isn't a singular reaction. It is a series of chain reactions. Not only is it a chain reaction, it actually increases exponentially. As we've seen, the first reaction during fission usually creates 2 or more neutrons, and these neutrons actually go and do the same thing. They smash into other isotope atoms present and keep multiplying and multiplying. 1 becomes 2, 2 becomes 4, 4 becomes 8, and so on. This is what fission is, a series of chain reactions that create energy by splitting atoms. In the real world, fission is mostly utilized in nuclear reactors to create harnessable energy. The fission used in nuclear plants uses uranium-235, but it utilizes it in a certain way. They specifically use weak uranium-235 to help control its fission better. Weaker means its chain reactions aren't as spontaneous and violent. This is because a nuclear plant's purpose is to harness energy. The slower, less violent reactions allow for the plant to efficiently harness energy from the fission reactions. Nuclear plants have even more measures to ensure slow and controlled fission reactions, such as putting the uranium in special long rods, spacing them apart, and cooling them with water. Nuclear weapons utilize uranium-235 and use the purest form possible. This is because their goal is to create catastrophic explosions, and the purer the uranium, the more violent and spontaneous it is. Nuclear weapons have no need for safety measures, so the uranium is put in a way that will allow it to react uncontrollably at the peak of explosion. Overall, fission is still relatively new and is still hiding many secrets. Scientists are working hard, exploring fission, and one day, new possibilities will come to life.